All right, thank you everyone for making it today on this off by one day for the OBO Academy. So I'm going to be walking through how to use AI coding apps for ontology development. Before we get started with the actual tutorial part in the demo, I'll walk through these slides just to give you a little bit of background on some of the concepts that we'll be going over today. Now, also in this slide deck, there's some preparation material as well, if you do want to follow along. I should say this tutorial is aimed at curators, ontology developers, non-technical users. You don't need any programming experience to be able to follow along here, even though this is about deploying software coding tools. It might require just a little bit of technical fiddling just to get a few things set up correctly on your computer. So if you want to zoom ahead in this slide deck, I think Nico dropped the link in, and you can do that as follow along as well. And if you have any questions anyway during this, just pop them in the chat, and hopefully someone can take care of them. But just to frame this, what we're interested in today is really helping scale up ontology development. So most of us here are either working on ontologies, developing ontologies, or making heavy use of them or contributing to them in some way. And we all know that most of these ontologies, they have issue trackers in GitHub, and they pretty much all of them have some backlog of tickets. And these are not just tickets for, can you make me a new term in branch X or branch Y? A lot of the tickets are to do with existing terms and how we might revise those terms or how we might rearrange the hierarchy. And it turns out a lot of these kinds of tickets are quite hard to address, because one thing that we suffer from in almost all of our ontologies, especially those that have been around a while, is a kind of ontological technical debt. There was maybe design decisions that were made 10 or so years ago, and we're still living with some of those decisions now, even if they made sense at the time, but they don't appear optimal in retrospect. So potentially AI can help us with a lot of the tasks that we face that are causing bottlenecks in all of our ontology repos. This can range from things like low-level term requests all the way through to kind of making changes en masse or in bulk, doing refactoring on ontologies, and even things like doing literature research or background research to help us understand a concept and how we might model it in the ontology. And one thing AI is particularly good for is summarizing and checking for adherence of either terms in the ontology or branches in the ontology to ontology design patterns or best practices. So that's all very well, talking about how we might use AI to do this in some mythical kind of far off future time. But what we're interested in today is how we can actually go about putting this directly into practice. So it can help to look in one area where AI is being used every single day by millions and millions of people to essentially enhance their workflows and boost their productivity. And that's essentially in the area of software engineering. So there's been a huge growth in AI coding tools, and in particular AI agentic coding tools. We can see on the right there's been a kind of evolution of use of AI in software development. These started out, essentially as glorified autocomplete inside software development environments. So the coder would start typing some text, and the AI would complete it. Moving on from that to a kind of paradigm where people would essentially post their questions into a chat interface like ChatGPT and say, write me some code to do X or Y. They would then paste that code back into their development environment, try and run it. Maybe it would work, maybe it wouldn't. They would paste the error back into the ChatGPT window. And people found that very useful, but it was a fairly inefficient way of working. So we've seen this evolution towards AI coding tools that are much more integrated into the workflows of software developers. Some of these are integrated directly into software development environments, and others are more like standalone software, standalone desktop user interfaces. And there's a whole slew of these, and it can be hard to keep up. But some you may have heard of would be Claude Code, not to be from the same people as Claude, but not to be confused with the Claude web application. There's something called Goose that we'll be talking about today. There's others like RuCode. It can be hard to keep up with all of these, but a lot of them are quite similar in practice. But the key question we want to talk about today is, can any of these be adapted from software development to ontology development? So before looking at how that might be done, just to kind of give you a sense of how these tools work for software developers. So, if we imagine maybe a developer who's perhaps a UI developer, they want to make a little standalone prototype of maybe a phenotype curation application. And they may be working with a curator or with a designer who's made some designs for the application in a separate application, like a drawing tool like Figma. So the coder might come along and say, okay, I want to make this phenotype curation app. There's some mockups in Figma, and they may talk to the AI coding tool. The AI coding tool is empowered via a plugin environment and something called the Model Context Protocol, such as able to talk to external tools, including tools like Figma. So it might go to Figma, pull all of the different figures that have been generated, pull that into its context window, develop a plan, maybe say, I want to develop this UI using the React framework, maybe use BioPortal or OLS to do autocomplete, generate the code, run it, do a few iterations if there's bugs in the code. And then it can show it to the developer, who may at this point want to participate more in the software development process, or they may want to step back a little bit and just let the coding tool produce the whole app from start to end. And there's a phrase you probably heard a little bit, which is called vibe coding, which is where you really turn up the dial on just sitting back and letting the AI do its work without any active control there. It turns out that's only useful in a certain limited set of circumstances, and the way most developers use these tools is as assistants and not as replacements for their work. Okay, so that's all very well for software and development. Can we adapt this for ontology development? Well, it turns out we've actually got a lot of experience in repurposing and adapting and adopting various kinds of software engineering workflows, strategies, patterns, and making use of them in ontology development, essentially moving from more artisanal ontology development to more of an ontology engineering strategy. So some examples of this are where software developers will use concepts like formal validation of programs and linting programs. We make use of things like OWL reasoners to be able to validate our ontologies and ensure that they're logically consistent. We use OWL reasoners to automatically classify branches within our ontologies. Software developers also pioneered the use of containerized continuous integration. This is something we've been adopting in ontology development for well over a decade now. And most of the ontologies that we work on are managed in GitHub. Anyone can come in and make changes in the form of pull requests. Those pull requests are validated using a containerized ontology development kit workflow that will then run these batteries of tests against the pull request. And finally, we also have our own equivalent to software integrated development environments in the form of ontology development environments. The primary one being the Protege ODE. So we definitely have a history in being able to repurpose a lot of these tools. So how might that work for an AI coding tool? So the basic idea here is that the ontology editor can come along and they can sit down at their desk, open their web browser into their favorite ontology issue tracker, see an issue that is high priority they might want to tackle, and then rather than firing up Protege to tackle it themselves, they open up some kind of like chat interface or terminal interface and basically ask the AI to fix the issue number. Now, this is different from doing something like going to ChatGPT and having a conversation where you paste in text from the issue. Here, the basic idea is that you can just give it the issue number, and it is enabled. It has tools enabled that allow it to essentially talk to GitHub and read the whole issue plus all surrounding comments on the issue, which might be something simple or like or maybe unspecified, like fix the lineage of the T3B cell. So after this, the AI coding agent might also have access to other tools like the Ontology Access Kit to be able to search for terms that it needs to be able to connect. So it may know that a T3B cell can develop from a T2B cell, but it may not have in its own knowledge or its own memory what the identifier for that is, or indeed if it's even in the ontology. So it can use tools like OAK to search for that. After it's found the term, got its ID, it can then make changes to the local copy of the file. And again, if you're using something like the standard ChatGPT web interface, it has no access to the files that you have on your hard drive. But the idea here is that we're using local tools, and it's actually able to go in, make the edits directly to the your ontology, execute robot via ODK, whatever, run a battery of tests, and it's even able to go ahead and make nice detailed commit messages and push a PR onto GitHub, where it may get reviewed by an AI coding review. So excellent, that's how it might work in practice. Just to kind of show you another way in which it might work in practice, and indeed a way in which it is being deployed right now with a number of different GitHub repos for ontologies, and that's integration of the tool with GitHub Actions. Most of these tools, you can run them essentially in batch mode, which makes it easy to integrate, just the same way we integrate things like Robot with our GitHub Actions. And the idea here is you can come to an AI-enabled repository and issue a magic keyword, and that keyword might be something like summoning or invoking the AI agent, which might have its own GitHub user account, so it will autocomplete. So in this case, many of our repos have been enabled with an agent called Dragon AI Agent. So you type at Dragon AI Agent, autocomplete space, then please. And again, it may be set up such that it only recognizes strictly this precise keyword because it wants to avoid accidental invocation of the AI. If you are more technical and you operate an ontology repo and you're interested in how you might be able to set up your own repo like this, it's a little bit technical, but there are some documents on this. And it's not such a big deal if you've already enabled GitHub Actions on your repository already. Okay, so once you have typed the invocation and your request, the request might also just refer to some previous comments in that same issue in the repo, or it can even link to other issues as well. The agent is able to fully read and even post on GitHub. So you might ask it to do review the ontology, do a literature search or something like that, post the findings on the issue. It may come back, do this literature search for concepts of relevance for populating your ontology, and then you can then go and ask it to go ahead and make further sub issues, and then have it automatically trigger such that pull requests are, so that the agent goes off and tackle those issues individually. So this is an example of a repo where this has been enabled. And of course, just as with any contributor to your repo, the idea is that you would review these AI contributions, and you would interact with it. And if it does something that you don't like, you can say, sorry, make this change, or go ahead and do it again. And you can keep doing that and iterate until it gets it right. Okay, but one of the challenges we face here, and this is something probably we're all familiar with to some extent, is that even in our nicely standardized bio-ontology world, we actually have a number of different ontology workflows. We've tried to account for this as much as possible within the ontology development kit. We allow people to essentially customize what I've broken out here as to three of the main workflows that people use. Now, the existence of these different workflows means that it can be hard to have a one-size-fits-all approach here. I'm very interested in helping you all with all of your ontology repos get set up using AI coding tools, but we'll encounter a few roadblocks along the way just because everyone has a slightly bespoke approach to all of this. But again, just to review what those workflows are, one of those is what I'll just call for simplicity here the OBO workflow. Of course, we're all OBO here, but the basic idea is that the source code for your ontology is all in OBO format. And some ontologies like Go and Uberon and Mondo make use of OBO format here, even though it's less expressive and it's got some maybe slightly undesirable computational properties. When it was designed to be a balance between that and human readability and editability. But the majority of repos in OBO make use of OWL as the source for their ontology. This is more precise, but it can be a bit harder for humans to operate directly on these OWL files, which is fine because most people will just use an ontology development environment like Protege to rather than hand editing the axioms in a text editor. And many of our ontologies like the cell ontology and Envo, the phenotype ontology repos make use of OWL as their source. And then finally, the other paradigm is people making use of tables such as TSVs managed in GitHub or spreadsheets and so on. And the basic idea here is those spreadsheets are the source of truth that people edit, and they will get converted to OWL using tools such that many of us are familiar with here, such as robot templates or DOSDB tools. Outside the OBO world, people are using things like Otter templates and so on. Now, of course, for a user, it doesn't really matter which of these workflows are used until that user maybe wants to contribute to the repo, because everything gets compiled to the same standard formats prior to release, and all the ontologies can be browsed on OLS and Bioportal onto B and so on. And of course, many people use some kind of mixture of these in their workflow. But as a kind of simplifying picture, it can help to think of things this way. And if we want to enable AI coding in these repos, then we have to be aware of what workflow we're using, because we want to essentially enable the AI to talk to our underlying source files via a pluggable architecture. So there's something that you may have heard of called MCP, stands for the Model Context Protocol. This is essentially a USB protocol for AI agents. It allows you to take a very generic AI application, a standard one that gives you some kind of text chat type interface, and allow you to essentially configure extensions for that, such that you can take whatever combination of extensions makes sense for your own particular bespoke workflow. And so this includes extensions for doing things like reading PDFs, for fetching things from the web, but it's also extensions for being able to do things like run a reasoner, which we don't have yet, or for talking to and making edits to the source file for your ontology setup. So a number of us have been prototyping this for OBO format type ontologies. It turns out AI is actually quite like OBO format for making edits. We've not actually MCP-ified this workflow yet, but if you're interested in doing this, it is possible. You just have to, don't laugh here, but you have to install a few Perl scripts on your in your environment for it to be able to run this. We'll update this at some point and make it a more modern MCP type environment, such as very easy to plug in from generic tools. But for now, it's we're not going to go over that today because it's a little bit fiddlier to get set up and running with it. There's also a preliminary OWL MCP. We're actually not going to be talking about that today. There's a few just quirks with how OWL gets serialized using different libraries that we need to resolve first before we can say this one is more production ready. But today, we're actually going to be talking about how to use the robot MCP, which allows you to allows the AI, I should say, to more easily interact with the robot templates that you have checked out in your repo. So if you are following along today and you're not using robot templates and you're not managing your ontologies or any portion of your ontology as TSVs or spreadsheets, then don't worry, because I think a lot of the principles that we're going to cover today and a lot of the questions that are going to come up will apply to any kind of ontology workflow. So with that, let's get started.
Before you go on, Chris,
Sure.
Nico, did you want to ask your question? I know you had your hand up
Please,
there.
yeah.
Yeah, sorry. So did you make any kind of like initial experiments with trying to basically translate everything into OBO format or some other kind of well understood lingua franca before you start using the workflows, and then basically making use of kind of just instead of having an OWL workflow, you just translate everything into OBO, do the edits, then translate everything back into OWL? Is there any kind of, other than the usual kind of representation issues with OWL and OBO, is there any other concerns you have with this kind of workflow?
The short answer is not yet. No. There's a lot of different kind of combinations of things that could be tried. And what I'm hoping to get out of today is to really, empower and enable a lot of you to try some of these experiments yourself, because the truth is none of us know exactly what kind of workflow will work best here. But I will say though that the convert everything to OBO type workflow is not ideal for something like robot templates, because we don't know how to go back. You convert it to OBO or OWL, you make edits. How do you save them back to the template? You can write kind of like custom robot exports, but it gets kind of fiddly. But yeah, sorry. The short answer is no, but I think it's a good thing to try.
Thanks.
All right, let's go on to the tutorial. So we'll do this interactively, or rather I've actually got some pre-recorded videos we'll walk through, but just to walk you through some of the basic installation steps. If you are on a Mac, this probably will only work if you have Xcode installed. Hopefully you have that installed by now. If not, try and follow along, and you can always try this later on. Next up, we're going to install a desktop version of one of these AI coding tools. You can actually try this workflow with a different AI coding tool if you like. You can download something like Claude Desktop, which is also a nice user-friendly interface. Again, not to be confused with the main Claude web interface. It's a standalone, it's a desktop application that can access local files, very similar to this. But the reason I'm recommending Goose as the one that we get started with is it actually provides you with two different front ends. It's got a command line interface front end, and it's got a desktop front end. And this makes it quite nice if you're working in a team where maybe the software developers can be using the command line interface and the non-technical people can be using the desktop. Anyway, this part is pretty straightforward here. You just go to this, you can Google it, you can go to this site here, download it for your platform. Unfortunately, I should have said this from the start, but there isn't a PC version at the moment. So yeah, I mean, you could try following this along with a different tool if you like. But what I suggest is you just kind of hold off, and we can talk about recommendations later. Make sure you download the desktop version, get that up and running. You should see a nice UI there. Now, the next step is, unfortunately, none of this works for free at the moment. This particular workflow works best if you give the AI access to the Claude family of models, in particular Claude Sonnet. For most people, this entails going to the Anthropic website and getting an API key. Now, I'm really interested in having all of you who are work at a large number of different organizations, and you each work on different projects. There are ways, I am sure, for each of you to be able to get some kind of institutional access or project-wide access. I know my own institute, this is pretty straightforward. I know those of you who are part of the Alliance of Genome Resources should have a way you can just get an Anthropic API key that will be charged centrally on the project. So I encourage you to look for your own kind of like project specific ways. But just for today, if you don't have that, then you can sign up for one. Yeah, don't worry, our demo today is not going to cost any more than 50 cents or so. If you have access to a different model like GPT-4o, you can try that as well, but I'm pretty sure it's not going to work as well just because the Claude models are very well tuned for this kind of agentic workflow. All right, and please just drop any questions you have in chat. I'm not going to be looking at them, but Nika or someone can, if I'm saying something that's completely unclear, just please interrupt, but otherwise someone on the chat can likely help you if you're having issues. So the next step is we're going to actually clone OB. You can clone the main OB repo, but what I suggest is you clone this this fork that we've made of it for demo purposes, and it's in a GitHub org called AI for Curation /OB tutorial. You can use this URL down here, or if you like, you don't actually have to use GitHub Desktop or the command line anymore. You can actually go into your tool like Goose, and you can just say, hey, clone me the fork of OB that is in AI for Curation /OB tutorial, and it'll figure out how to use Git for you. Again, it'll probably only work with Xcode installed if you're on a Mac. All right, so any questions so far before we go into the, the part I didn't actually mention here is you will also want to go into the interface as well, and then you'll want to go to, move this to the side, advanced, and then advanced settings, and then configure providers. This is where you'll want to go and say, pick Anthropic over here. You paste in your API key. This should be filled in automatically. Once you've done that, you can then access any of the Claude models, and I suggest picking the latest one, Claude 3 Sonnet.
Chris, for
Yeah.
the OB tutorial link, can you very briefly summarize how you modified this so that we can modify our own ontologies while we are listening to you quickly? Is there a lot of modification that happened, or?
No, that's good. Yeah, sorry, I should have mentioned that. No, there's one single modification. There's one file that has been added into the root of the repo, and it's called a Goose Hints file. All of these AI coding tools typically make use of an optional file that gives the AI some context about your project and what some of the best practices are. So that's a very good point. Let's just, okay, I'll go back to sharing in 2 seconds, but we can look at the repo just now. So the one change is, and you can just go ahead and apply this change yourself. If you are an OB developer and you want to make the change in your own local checkout, just copy this one file across, and it's got some hints for working with OB. It just explains the repository layout, but this mostly focuses on describing the templates, because we don't necessarily need the AI. Many of our ontology repos are quite complex with lots of little sidecar files here and there. So really we just want it to focus on the files that it's going to be editing. So here's the, sorry, I can zoom this in a little bit. It's the TSVs. And this is a pretty minimal set of instructions. What you'll probably find as you become more familiar with these tools is you want to tune these instructions either for your own personal workflow or for the workflows of your own project. So, any other questions, or should we get started with the actual interactive part. All right, so what we're going to do first of all is we're going to configure Goose such that go to advanced settings, and then we're going to scroll to add custom extension, and then you can give this extension whatever name you like, but I suggest you call it Robot MCP because that's its proper name. And then within this command box, you're going to type something very simple, and I can pause here. Oh, sorry, I didn't pause in time. Well, it doesn't matter. You can see it here anyway. Just if it tells you that you've successfully activated the extension, and then it's just UVX space Robot MCP. Now in your main Goose interface, you can do whatever you like right now, but you can ask it to describe the extension, and it will go off, have a think about it. It will kind of introspect its own set of plugins, and then it will come back with a description of that extension. It's maybe a little bit kind of like more low level than you need to know about, but we'll be talking about the technical implementation of this in a moment. But the basic idea is that this extension helps the AI find the robot templates in that repository. So how are we all getting on with configuration? Any questions in chat? Should we take a pause for just people to catch up there? All right, so I hear silence. So either everyone is up and running with this, or maybe you've just decided that you're just going to watch along and try this at home later.
Actually, can you just show sorry if it's in the
Yeah.
already. Can you just show the configuration of Goose again to make sure we get the right command for the robot MCP?
Yeah. And sorry, there's actually an even easier way to do this. It's very easy for us to set up a little install link button that we can put on a page, but here it is again. And again, you don't worry, ignore everything else. Just you need to give it some kind of name, but this is the magic invocation here: UVX space robot hyphen MCP. All right. Let's move on then to the next part. I'll show again. All right, so now we're actually going to get started, and we're going to tackle an issue that is there. But the very first thing we're going to do is we're going to navigate to wherever we've got OB checked out in. Oh, sorry, I'm trying to pause here and it just restarts it. Okay, apologies for that. So here you should see in the little selection bar in the top is just a standard file navigation browser. So I happen to have all my repos checked out in a folder called repos. You may have yours checked out in desktop, wherever. And I've got the main OB repo here, but you may have the OBO tutorial repo checked out. So if you can navigate your file system, you should be able to handle this part quite easily. So next, let's go ahead and start by just summarizing what we're going to orient ourselves and the AI itself by just asking for a summary of the templates that are in the repo. It should already know this from its Goose hints, but maybe we've not updated the Goose hints in a while, and it wants to do just a fresh look. Just there's maybe new templates that have been added there. So even though this UI it's intended to be a kind of reasonably user-friendly desktop UI, it is kind of chatty, and it will tell you what it's doing all the time. Most of the time you can actually ignore this, but it can actually be helpful to get a sense of how it's working, to actually look at the tools that it's using. So I'm going to just pause here for a moment. So, a key concept here is this idea of tool use. And this is something that sets agentic AI apart from other kinds of other AI, such as just directly interacting with ChatGPT through a web interface. So here is interacting with the robot MCP tool. Doesn't make it super obvious that that's the MCP it's using, but it's giving you the human-friendly name of the tool within the MCP server that it's using. And here it's like just the execute SQL tool. And the basic idea here is that we're allowing it to have the full power of SQL when editing robot templates. And we'll see later that's actually quite a powerful way of interacting with these files, especially as they become larger and larger. The OB assays has about 1,000 terms within it, but some of us may be working on repos where we have even bigger sets of terms managed as essentially as tables. So it's just doing this select count as a kind of like a summary step. You don't need to know any SQL here, but it's this can be a kind of like nice way to learn exactly how you might use some of these commands yourself in the future. Okay, so it's done. It's queried all of the different templates. It's got actual kind of like counts, so up-to-date counts of these, and it's made its own kind of like inferences and summaries because and some of this is coming from the hints as well, and it's telling you just a little bit of kind of how robot templates work. All right, so for those of you following along, first of all, I'm curious, did that work? Did it not work for anyone? Or all right, okay, good. So next, let's simulate part of a normal ontology development workflow, which might involve tackling an issue in a GitHub repository. So we picked this one, the relatively recent one, in the OB repo about changes to the comment assay. This involves changing definitions, moving the term, deepening the placement of the term within the ontology. We don't need to go over the full issue itself, because in fact we can just kind of vibe code this essentially and not even read the issue, but just say, I want to help you with issue number 1867. It's already in the OB, your local checked out version of the OB repo. You don't need to give it any more context. It knows what issue 1867 is. And you can either give it specific instructions about how you'd like it to tackle this, or you can just say, go ahead and figure this out for yourself. And so again, we can follow the tool use to see what it's doing. You don't need to do this, but it can be useful. So here you can see it's using the GH command on the command line to view this. No, it doesn't actually need to append this on the end. For recording this, I just had external access to OB switched off just to stop the agent from accidentally making chit chat on the ontology repo. So what it's doing next is it's using again the execute SQL tool within the robot MCP to look and see what exists for this existing assay, this comment assay. So it's doing essentially a select star from assays where the ontology ID or the ontology term ID is equal to that OB ID. It goes off and has a think about that. It's got a sense of this, and then it's basically just making the change, rather than going into something like Protege, because this is a robot template repo. It can just do it by just updating one value in a particular row, just using a SQL update. All right, so it continues to give you some chit chat about changes that it's made. Now, the next step is another step where you might get caught up here. What it's doing is that it's actually now deciding to go off and validate the changes that it made, and it's actually going off it's compiled the individual module. So the way robot templates work is that there's modules made for each of the underlying TSVs. In this case, assays TSV gets turned into assays.al, that worked successfully. Now it's going to see if it can get the entire repo working. Now at this stage, OB is not set up to use the ODK. OB is set up a slightly different way than if you're not already an OB developer, you may be used to. The make file itself takes care of issues like installing robot, which may or may not work in your environment. So if you're following along and the agent has decided to go off and run make test, I'm sorry, I restarted that. Let's go back to where we left off. So how are we all getting on so far? Okay, now of course make test can take some time, and I rewind part of the video, sorry, so it's going to take even longer here, but we can you can flash forward a little bit to where it's successfully run make test, and then we can have it rebuild the entire ontology locally. And then we can look at it in Protege. So let's just review the issue again. It is about changing the parent of this assay term. Just we can see how it looks right now today. Comment assay is underneath fluorescence detection assay. And then bingo, in our local version, the version that we can see in Protege, it has moved to the correct place. And the definition has been updated in accordance with the request that was in the GitHub issue. All right. Yes, the textual definition was also changed. All right.
Chris, can you estimate how intense the API usage is for your interactions so far through Goose? Like how many requests were they to the API Claude, for example?
Yeah, you could see it in the there was a dozen or so, I think, there, but it can vary a lot because hardware requests can essentially cause it to make many successive iterative requests, but so it's hard to estimate, but the big picture here is that it's not super cheap necessarily to run these. You don't want to be paying out of pocket for this, but overall, once we get familiar set up using these, the efficiency gains are pretty huge. So okay, how did that all work for everyone? Were you able to was it able to go off, make the relevant edits? Did it completely crash and burn? I'm also curious if anyone is using a different AI model like GPT for David's out of tokens. Okay, sorry about that. All right, so I'll give people another few seconds just to kind of like catch up there. Then we're going to try a slightly different workflow. This one is not going to be driven necessarily by a GitHub issue, but we may be just coming to OB, and we may be interested in a particular area, like maybe we're using this to build a value set for our genomics database, and we want to have a controlled field that is the sequencing device that was used. And we may want more up-to-date terms for DNA sequencers within OB. So first of all, let's just ask it for what it knows about DNA sequencers, and it's kind of smart enough to figure out that these probably belong in the devices table or template. So it goes off, performs various queries on each of these. And one thing that's slightly annoying is that if the tool returns a table with multiple rows, you'll see like output, 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 which is not super intuitive to me, but I don't know if anyone's got any tips for dealing with that. Anyway, so it's given us its own interpretation. It's kind of figured out the hierarchy from, even though the table itself is flat, it's got parents in there, so it's given us kind of like a summary of both the actual sequencers themselves plus how they are represented. All right, so let's just generically go off and do a web search, find what some of the latest DNA sequencing technology is, what new machines or devices might be out as of to this year. It can help to tell it what the current year is. Sometimes these AI models think they're living in the past, and it may do a search for 2024. And here I'm also telling it which ID range to use when making new term requests. This ID range issue is something that's not been fully resolved yet. Even if you tell it what ID range to use, and you have multiple different pull requests that are open, there's not an easy way to kind of communicate between those. So we're working on solutions for this. So it's going off and it's doing a web search. Now it's able to just use kind of generic tools to do a web search, but I've got a different MCP installed here called Heavily, but it essentially should give you the same results. So I'm just kind of like clicking on some of the links here just to make sure it's not hallucinating any of these references. It's going off and it's doing a deeper dive on some of these. I didn't tell it to kind of prioritize things like NIH websites and so on, but it's chosen to make use of some information here, and so on and so on. And so based on its research, it's now decided to add missing terms within the ID range for some of these platforms here. So it gets itself set up. Creates entries for the missing sequencers. It does a double check just to make sure it knows what the correct structure is. Let's pause for a second here. Just again, you don't need to know the actual details of how it's working, but if you want to see how the sausage is made, you can kind of like pop open this thing here, and you can see it's basically doing a straightforward SQL insert into the devices table, filling in the term ID, the label, the editor preferred term, definition of source, parent, and so on. So these are pretty straightforward. They go directly under the term DNA sequencer. It includes the URL. It will occasionally kind of like make some syntax error, especially just because the robot templates might have spaces within the column header, so it's got to kind of escape those in the right way, and this isn't always standardized well across different SQL dialects and so on. So there's a few things that it it fumbles on, but then it corrects itself, and maybe we could do a better job there of making the actual tool itself speak more of a universal SQL there. But anyway, you can see it's gone ahead and it's added those into the TSV. If we had maybe a text editor open at the same time, we could see those changes to the TSV. But I'm just going to go ahead and ask it to compile the OWL module from the TSV. It'll go ahead, build that OWL module. Again, you can't see the full command here, but it's essentially just using the standard OB makefile, which makes use of robot to compile the OWL from the TSV. All right, it's done that, and it's going, Goose can sometimes be a little bit overeager. I didn't ask it to do this, but I think it's a reasonable thing. It's now going to go ahead and just rebuild the entire ontology from there, and it will go off and it's a little bit fastidious. It'll go off and do little checks looking at the actual files themselves just to make sure that, because it doesn't necessarily trust itself, that the OWL module has successfully been rebuilt and incorporated some of our new terms here. And again, it's going off to run the full makefile. So we can zoom ahead to when it's done this, and we can go and look under DNA sequencer. And again, we can see here's some of the actual terms that it's made. Yeah, so let's go and search one of the ones they've kind of like found. So just using the standard Protégé search just to convince ourselves that it did work. So this was not in the OB before, but it's got a new OBID within this 0.7 range. Sorry, I cut off a little bit quickly there, but you can see it is there. Sorry, the video truncated itself, but hopefully that gives you the basic idea there. With that, I'll maybe stop the share. We've got 10 minutes. There are some additional tutorials here for working with the very preliminary OWL MCP workflow, but the one that has been tested the most is the OBO one. All right, I wasn't checking chat for the most part during that, but I'm curious how. Raise your hands if you, or raise your virtual Zoom hand if you manage to get some or part of that working. Yay! All right.
Chris, I do have a question for
Yeah.
you, and you know what this is coming. So a lot of time, every time I ask something, there's always something that is not quite what I want, because we have every ontologies have their own rules. And so in order to get what I want, I need to ask and and every time I need to add another prompt of like do this. How can we make sure that we get this straightforward, so that when I ask for a new term, let's say, it knows it needs to add a cross-reference for this, let's say the synonyms, this sort of things. How can we get that so that we spend less time and then we don't have to keep track of these are all the things I need to remember to tell it to do?
Exactly, yeah. And some of you have already been interacting with the agent on various different GitHub repositories. And you may have kind of like hit this where it's like it made a term, but it didn't. For this particular ontology, we like to include this particular piece of metadata. When we originally rolled some of these out, we just gave it minimal generic instructions. It turns out then that becomes kind of quite frustrating, because you've got to go back and say, no, we always add PMIDs on the synonyms in this ontology and so on. So the way, broadly the way to do this is that we just take those instructions and include them in the hints file, or the CloudMD file that is managed by that individual repo. And we've been getting much better results if we move away from these very generic descriptions that we've been giving to giving something that's a bit more like design patterns, but not exactly. But it works really, really well with examples and counterexamples. So this is not checked into some of our repos yet, but in a separate eval repo, we've been trying things like giving it a stanza, like this is an OBO format stanza for this ontology. This is what it should look like. Should generally have a part of relationship, and so on and so on. It does a lot better of these. Now, the key question is like, okay, how do we get there? How do we, how do I, as an ontology developer, write the optimal instructions for an AI? And the short answer is we don't know exactly yet, but we're coming up with kind of evals and test harnesses. We can do things now like take all the PRs in a repo and then run them through a particular AI configuration, evaluate how well it does, and then kind of like tweak that and change that and move forward. But the short answer is, I think very soon we're going to come up with a set of standard patterns for how we provide the AI with instructions to optimally make the kinds of changes that we need in our repositories. And if you move away from using like the GitHub interface to using something like Claude Code or Goose, you can actually ask it to update its instructions as it goes along. So maybe it does something wrong. You say, no, that's not how we do things here. Do it like this. Add something to your instructions such that future people will get the benefits of your improved learning. So, sorry, a bit of a wordy answer, but that's the basic idea.
And related to this update, so basically while I'm playing with the AI and trying to explain it to do things better, like I do realize I can tell it in the chat to do it better, but ideally, of course, I realize, okay, it doesn't understand our obsolescence workflow, so I provide the obsolescence workflow, I document it in Goose Hints, but then it seems to want me to restart the session because it can't reread the Goose hints file. So do you have a specific workflow on how to best interact and document the SOPs at the same time as testing new things?
Yeah, the short answer is no, and I think it's hard. Some of these tools are new and they're changing, and you can make an issue on their tracker, and maybe they will kind of like fix that so that it auto refreshes. But it may be slightly different for a different tool. So I think if you are using this in this very kind of like cutting edge way, yeah, there's going to be an aspect of just kind of like learning and kind of coming up with what works best for you. But obviously, we hope to get to a stage soon where these instructions become relatively stable, and we can just share them. David. Mm-hmm.
Oh, you're muted, David.
A couple of questions. One is, we're stuck with the OWL repos right now, so things are going really nicely with Uberon, and we're starting to edit and update. But do you think a reasonable workflow might be to use robot templates to add new? So you could imagine a workflow where you got the AI to make a temporary robot template plus a TSV, ran robot merge, and then gave you a new. Do you think that might be a quick way for us to start getting draft term edition?
Yeah, we could definitely do that, and especially for repo, different ontologies kind of like have different needs in terms of like CL might be more focused on new TOM requests and other repos. That could be a great way to just integrate it. My gut feeling though is that trying to come up with a more uniform workflow that reflects the workflow that ontology editors already use is just going to work best, because you avoid this kind of proliferation of documentation and like, oh, if you're doing this, do it this way, and so on. But yeah, ultimately, I don't actually know the answer to that.
Cool. I noticed, so you're actually using, I guess, latent knowledge in the LLMs to add content there to put in a set of sequencer models. But presumably the big danger there is that it will just hallucinate a new sequencer model. So are you using, in this case, something which will bring back references? We're sort of really focused on the tools that will give us references so that we can check things quickly.
Yeah. In that particular example, it was doing like a web search just because, obviously for most of our ontologies, we want to use PubMed IDs, but you're not necessarily going to have a PubMed ID that's dedicated to the singular genomics G4 sequencer. So it should have been using the results of its web search rather than latent knowledge. But as you know, kind of like a key challenge with some of these tools is just getting that balance just right and avoiding that.
And that's why, I mean, so we're actually looking at one of the first tools we're working on is using that paper QA tool to actually have an agent that pulls references from on a pull request. The definition has references, pull those references, put those into RAG, and pull out the assertions that the term makes logically and textually, and then test those against the references. I think it's really useful to do that generally as well. And we could do that with manually added terms as well. But that strikes me. I think having that kind of feedback where there's a second check for quality, I think is really important, and in a way that kind of gives the editors some rapid feedback system that they can work with effectively. Because definitely we've been using LLMs to roll definitions, and sometimes hallucinations do creep through.
And Nico makes a good point there that you don't necessarily need to use some MCP or tool. You can just ask Goose to go and edit your OWL file directly. That may be a perfectly good workflow, but in our limited experience when we try this, it tends to get kind of like confused by larger files, and it's just as it would be a suboptimal way for a human to make changes to the ontology, it can be for the agent as well. But maybe if you've got a smaller ontology, that could work perfectly well, and that could be just a really simple workflow where you don't you just have the coding tool directly edit it. All right, well, that takes us to time, but please follow up with any questions you may have just in the remaining 10 seconds. I just wanted to very quickly throw up a very quick thank you screen. And we just, so it's there in the video. So thank you everyone who has been testing some of the earlier versions of this. And thanks especially to everyone who helped put some of these tools together, and to the OBO Academy people for making this all happen. And follow up, just Slack, email if you've got any questions. Try this. If you didn't get a chance to run through today, try it again and let us know how you get on. And we will be continually updating and improving these workflows. So thanks for your attention, everyone.